Okay, example 1. Um, this question is asking us to first draw the graph y equals x squared plus 3x minus 10 and then use the graph to solve the inequality x squared plus 3x minus 10 being greater or equal to 0. Now the first step to this question is to draw this, and to do this we can factorize, then sketch. Wouldn't recommend drawing everything. Okay, so first thing we need to do is solve or find the roots of this quadratic. Now the roots of any quadratic is at this point and at this point, and at these 2 points the y value is 0. So any quadratic with a root has a y value of 0. So what we're going to do with this is just equate it to 0 and find out where it crosses the x-axis. And we know how to do this. Firstly, factorize quadratic. There is no x term as a factor. Sorry, there's no x as a factor of this last term. So we can have 2 brackets, 2 numbers times together is minus 10, add together is 3, and that is plus 5x minus 2. Now inside this bracket, for this expression, or these 2 brackets to equal 0, x must be minus 5, and if x was positive 2, this bracket would be 0, and anything times 0 is 0. So we find out our roots when y equals 0. Okay, so let's do a proper sketch. I'm going to move this over here, and for our sketch, very quickly, I'm just going to draw our axes. So here's our first one, and so here's our x, and it crosses at minus 5. Say this is minus 5, and it crosses at 2, and our quadratic would look something like this. So here's our quadratic. Now how is this going to help us? We'll find out part B. Now part B is asking us to solve the inequality. So I'm going to use the graph. We're going to use the graph. Let's move it over here. Let's use the graph to solve the inequality. It's saying, when is x squared plus 3x minus 10 bigger or greater to 0? Now we can replace this expression with y, because that's what our y is. So when is y greater or bigger than 0? Well, anything above the x-axis, y is bigger than 0. Whoops, went over a little bit. So anything above the x-axis over here, y is bigger than 0. And where is our line that's bigger than 0? Well, we have this. This is bigger than 0, and this is bigger than 0. So we need to form an inequality for this line, or these 2 lines. Now, when x carries on going after 2, our y gets bigger and bigger and bigger. It doesn't go into the negatives. So when x is bigger and equal to 2, our y is always positive. And when x goes this way, our y's are always positive. So when x is less than and equal to minus 5, our y's are always positive. And here is our 2 inequalities. Now the reason why we have an equal to, because in our inequality, or in the question, it's asking when is y greater or equal to 0. If x was equal to 2, then 2 squared is 4, plus 3 times 4 is 3 times 2 is 6, minus 10 is 0. So y could also equal 0. And if x was minus 5, you can substitute it in there. You will also get y is equal to 5. So it could equal to 0, hence why we have the inequality signs for this as well. Now, I'm going to create my own question with this example. Now, let's pretend instead of asking us when x squared plus 3x minus 10 is greater than or equal to 0, when is it less than or equal to 10? Sorry, less than or equal to 0. When is it less than or equal to 0? Now, if we look at our graph once more, or before we do that, let's just say this is still a y equals to x squared plus 3x minus 10. So when is y less than or equal to 0? Well, looking at our graph, this is your x line, x-axis. Any point below the x-axis, your y's are negative. And these points here are negative. Your y's are negative. So we need to create an inequality for those. Now, when x goes this way, your y's gets negative. And when x goes this way, your y's are also negative. We need to have an inequality for us to describe this part of the line. Now, when x is between or less than or equal to 2, because we're going to the left of 2, and it is bigger or equal to minus 5, your y values are below the x line, or y values are negative. So for this question, when it's less than or equal to, would be this inequality. You can even check, pick any x value between minus 5 and 2. If you pick 0, 0 is between minus 5 and 2, 0 squared is 0, plus 3 times 0 is 0, minus 10 is minus 10, so your y is minus 10. Can you see? Your y is a negative and it's below the line. X-axis. And that's done. So those two questions that we answered, one when it is greater or equal to 0, which is these two inequalities, so you got not just one but two inequalities, and when it's less than or equal to 0, otherwise below the x-axis, you have a single inequality that describes it. Okay, let's move on to example 2. Now this example isn't telling us to sketch it, it just tells us to solve the inequality. Always do a sketch. Okay, so we're going to start off with our axes again. So let me see if I can make the line a little bit thicker. So here's our y-axis, and here is our x-axis. The next thing you want to do is find a root. So where does it cross our x-axis? Where does it cross it? So we need to factorize this expression, and to do this, because we have x as a common factor on both terms, all we need is a single bracket. And that would be x, bracket x minus 6, and that is less than 0. So if our x was 0, then 0 times anything inside the brackets is going to be 0. So we got one root. And if our x was 6, then 6 minus 6 is 0, so inside this bracket is 0, and 0 times anything outside the brackets is 0, so here's our other root, 6. I'm going to put a 0 here just to say that crosses the origin. So our line is going to go somewhere like this. It's going to cross 0 and it's going to cross 6. And here's our quadratic function or line. Okay, the next thing we need to do is solve it. So, remember, this is just like y equals x squared minus 6x. It's a line, it's a relationship between x and y. Now, when is y less than 0? Well, anything below the line, your y is less than 0. In other words, it is a negative. And we need to find the inequality that satisfies this line. So we need to find values of x that makes y less than 0. Now, if our x was to go this way, because any x that's on left of 6, is going to produce y values which are less than 0, and any values of x more than 0 is going to produce y values that are less than 0 as well. So our inequality would be x is less than 6 but bigger than 0. There is no equal sign because we don't have an equal sign without inequality from the question. So your x values are going to be between 0 and 6. And you can check, pick any value of x that's between 0 and 6, put it into there. If it is less than 0, you're pretty sure you're right. If it is not, then you've probably made a substitution error, so you need to check again. Or you 100% sure with your substitution, then your inequality is probably wrong. So I like to pick something easy. Let's say x is 2. 2 squared is 4. Minus 12. Is 4 minus 12 less than 0? Yes, it is. So we are somewhat sure that our question or our solution is correct. Now I'm going to create my own question once more. This time we're going to say the question is asking us to solve the inequality x squared minus 6x is greater than 0. Again, I want to create my... Being too lazy here. Am I being lazy? Probably. Would it work? No. I have to create my own. Okay, no big deal. Again, let's create our axes. And can I copy this line? Nope, seems to have attached itself. Okay, so we've already done the hard parts. We've factorized it. We've solved the roots. So the roots for this is going to be the same as that. I mean, if you really like, you can factorize it again. Greater than 0, x is still the same, x is 0, and still the same, x is a positive 6. So it would cross somewhere, it will cross definitely at 6 and 0, and our line would still go through 0 and 6. But this time the inequality is asking us where x squared minus 6x is greater than 0. Just one more time, remember, y is x squared minus 6x. And when is y bigger than 0? When is y a positive? And y being a positive is above the x-axis, and this line is above the x-axis, and this line is above the x-axis. So the region that's the blue is the region, the darker blue is our line. Now going back to the question, so when is our line getting bigger? When x goes to the right of 6. So whenever x is bigger than 6, our y gets bigger and it stays positive. And when is our y, also on this side we need to watch out, when is our y getting bigger or staying positive, is when our, really bad colour choice, when our x is getting smaller than 0, or x is going left to the left. So x is smaller than 0, our y is increasing or is staying positive. And that's it. This is our inequality for x. We have two values, two inequalities, and we're done. This is the solution to our question, and we're finished. Pretty simple. Okay, this last one, if you remember our little investigation, when we got minus x squared, we have a minus x squared, so forget about this 25 for now. If we have a minus x squared, our quadratic would be reflected in the x-axis, in other words upside down, and the 25 is going to shift it up 25 spaces. So this would be the maximum, which is 25. Now, we can solve this in this way, and we can find out the roots, but what I like doing is factorizing with the positives. So what I like to do with this question, you need to pay attention now, is go back a few steps. So rewrite the question. Instead of having an inequality, put equal to 0. So this is the tools that's going to help us answer this question for now. Now, multiply everything on the left hand side by -1, and to balance we have to multiply everything on the right hand side by -1. This 25 becomes a -25, this minus x squared becomes a plus x squared, and the 0 just becomes a 0, stays a 0. Tidying this up, x squared minus 25 is equal to 0. Now we can factorize this. Difference of two squares, x plus 5 and x minus 5. Okay. Also, what we could have done, in fact, is solved it this way. Plus x squared on both sides, plus x squared on both sides. So we get 25 is equal to x squared, square root and square root. So our x could be a 5, or our x is a minus 5. Now, I'm going to step back and explain to you, because some of you would be asking, what's he doing? What? And that's going to go in your head. And remember, we're trying to find out the roots, or where it crosses the y-axis. Hence why it's equal to 0. Our y is equal to 0. And it gave us the x values of when y is equal to 0. 5 squared is 25. 25 minus 25 is 0. Minus 5 squared is 25. 25 minus 25 is 0. So we figured out where the roots are. The roots are at minus 5 and at 5. Now, when is the quadratic bigger than 0? Is when x goes to the right of minus 5 and to the left of 5. Hence we get positive values of y. So x is between 5 and minus 5. That is when y is positive. Now, if you don't like this question, I understand why. Bear with me, we'll answer it differently. I gave up on this because I like this more. But you can always do it like this as well. So x here will do minus 5, and x over here would be 5. So we still find out the roots. Now let's answer it in a different way. Okay. So what I'm going to do is very quickly duplicate, and I'm going to clear, and let's start the question anew. So it's asking us to solve this inequality. Now, to do this, multiply everything by minus 1. I don't like the minus x squared. Multiply everything, every single term on the left and right by minus 1. So you get minus 25 plus x squared. Now, what is going to happen to our inequality when we multiply by minus 1? What do we find out? The inequality is going to switch to the other way around. And it's still going to be a 0 there. I'm going to just tidy this up. That's going to be x squared minus 25 is less than 0. Factorize, because we're going to find out the roots. We're going to find out what this graph or what this equation looks like. So we're going to factorize. Difference of two squares, x minus 5, x plus 5, and that is less than 0. So our roots is when x is 5 and when x is minus 5. X is 5 minus 5. Now this is the quadratic that we drew, and it's going to look something like this. Now, for what values of x, we're going to start answering the question now. For what values of x is x squared minus 25 less than 0? Remember, we're going to be looking at this now, because this is what we sketched. This is the sketch of that. This here, 25 minus x squared, is the sketch of this graph, which is upside down. So we're going to be talking about it when it's less than 0, and that is between, so x is between, sorry, that's supposed to be a positive 5, so x is between 5 and minus 5. That is when the graph, or when y values are less than 0. And if you look, this answer is exactly the same as what we had here. But the graph looks different. But the inequality that we switched around makes sense, and it does well. What I need you to do for homework is answer a few inequality style questions. Let me see. So a few questions. You can take a look at example. Question 1, 2. I wouldn't try to go through it in class if you didn't understand the last example, but if you want to have a go at it as a challenge, you're more than welcome to. Use the graph to solve. Yeah. Question 3. Question 4 looks interesting as well. Question 5. Yeah, 5 looks interesting. But remember, if you're going to be solving it the other way around, times it by minus, make sure this x becomes a minus, this x squared becomes a positive. Always remember the inequality changes sign. Again, this becomes a minus, this becomes a positive, the inequality changes direction again. And is almost it. So again, these are going to be a difference of 2 squares. Nine minus 9 and 3, yeah, and this looks nice as well. I won't give you too many, I'm just looking at the questions and telling you some ideas. So again, you're going to be factorizing this. If this question comes up, every term is going to be factorized. So this is a minus 9 and 3, this is a 4 and 3, this is minus 8 to minus 5, this is minus 9, I believe, and 2. So you're going to find out the roots and find out the inequality. Watch out for the signs. This I would recommend. Factorize it if you wish, but multiply it by minus 1 if you want to sketch it, and state the solutions of the inequality. I don't even understand why they decided to change that about. Okay, and that is it. Pretty simple. Sketching, solving, sketching, and solving. Okay, good luck. Next homework is going to be on Wednesday.